And here we go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Liftoff of Falcon Heavy with Europa Clipper, unveiling the mysteries of an enormous ocean lurking beneath the icy crust of Jupiter's moon, Europa.
Engine chamber pressures are nominal.
See that the chamber pressures are nominal as we hear. All 27 Merlin engines look great.
Rocket beginning to roll. Putting down 5.1 million pounds of thrust. Coming up, they're going to back off those engines just a bit.
So we're getting ready to head into max
Power
Q.
and telemetry nominal.
We hear that power and telemetry on the vehicle are good there. Everything's looking really
Falcon
well.
Heavy is supersonic.
They have reduced power in the center core to get through max Q, maximum dynamic pressure on the launch vehicle as we approach that. The two side boosters at full throttle.
A beautiful shot there as our camera team
Max Q.
locking into the rocket on a clear blue sky. The view from the booster cam back down on Earth.
And there we heard the call for max Q. The vehicle is passing through maximum dynamic pressure. Next thing up in about 2 minutes will be booster engine cutoff, where we see the two side booster engines, all 18, shut down and get ready for booster separation. But the vehicle is performing very well. Looking at all the telemetry that we have, power and trajectory are nominal.
We've been flying for just under 2 minutes so far. Everything looking good. These side boosters, once they do their job, they will be expended. If you're familiar with the Falcon Heavy, you know that they bring the boosters back on certain launches, but not on this one, because all of the performance is needed to push Europa Clipper into its proper orbit.
Things continue to look good as the vehicle heads down its ascent phase here. All telemetry is looking very nominal for this flight this morning. Falcon Heavy is performing very well.
Now we're just about 30 seconds away from separating those side boosters. Their engines will cut off first, then they will separate.
MVAC is chilling.
Starting to chill down that MVAC-D engine in the second stage.
And that's where we need to get the engine chilled to the proper temperatures before flowing liquid oxygen and RP1 into it. So they're conditioning the engine to make sure things are ready for when it's ready to start up.
Stand by for booster separation.
Booster engine cutoff. Side booster separation confirmed.
And there they go.
Those two boosters previously flown on Psyche. This will be their 6th flight. We thank you for their service this morning. They did a great job of getting Falcon Heavy and Europa Clipper on its way as the center core takes over and continues mission down its ascent. Things are looking really good in the telemetry. Power and trajectory look nominal, and chamber pressures on the 9 center core engines look really good.
In just a little more 20 seconds from now, we'll get the cutoff of the main engine on the center core booster that remains. 4 seconds after that, we will separate. Flying out over the Atlantic Ocean. There's a look from inside.
There we see stage 1
Stage separation confirmed.
And stage separation from the center core. Getting ready for MVAC startup, SES-1.
We're getting some applause here in the Mission Directors Center, and there you see the MVAC-D engine lighting up.
Next thing up in about 10 seconds will be fairing separation.
NYPY FTS has saved.
And the fairing has protected Europa Clipper on its ascent up into space, but once we get into space, we don't need that fairing anymore.
Fairing
there they go.
separation confirmed.
fairing has separated, and those will be recovered, Daryl, by SpaceX's own recovery ship, Go Cosmos.
And there you see them falling away into space. That is the only part of this rocket that will be recovered.
The glow of the MVAC-D engine as it performs its first burn here. This is about a 3-minute and 47-second burn. Things are looking great. Matter of fact, this is one of the shortest first burns that has been done on a Falcon Heavy by SpaceX, but it is required to get us into that parking orbit for that long coast that we have to get ready for the interplanetary trajectory that we're going to need to get Europa Clipper on its way that we heard Jenny talk about to get those Earth Assist slingshots as it heads on its way for its mission. So things looking really good this morning with the performance of the Falcon Heavy. MVAC is performing well, and everything looks good thus far in today's mission.
Usually those burns are the other way around, with a longer first burn and the shorter second burn, but in this case it is reversed. As we look at some crystal clear views of the MVAC-D engine, the stage 2 that's carrying Europa Clipper, orbital light is shining both on the spacecraft, the second stage, and on planet Earth.
Center core FPS
beautiful.
has saved.
There we've heard that the flight termination system on the center core has been saved as it heads back to splash down. Things are looking good. I can tell you, Daryl, we had a beautiful weather day for launch, and as we're looking at MVAC flying in space with Europa Clipper, it is such a gorgeous view with Earth behind it, and so we could not have had a better day for a mission launch today.
No doubt about it, Mick. It was simply gorgeous. We had a hurricane a week ago, but after that pushed out, it brought us in its wake near perfect weather for launch. And now we're into space, dealing with the harsh conditions up there.
Stage 2 FTS is saved.
Stage 2 has made its way into space, far enough away for us to be able to safe the flight termination system from a safety perspective. We're about a minute away from second stage engine cutoff as we'll see the MVAC-D shut down and get ready for a long coast, getting Europa Clipper into that parking orbit and on its way for the next firing that we will have, the second stage, number 2, to get it into that interplanetary transfer orbit that we need to get Europa Clipper started. So things looking very well this morning. We're about 30 seconds from that stage engine cutoff, which we refer to as SECO 1.
Stage
That's right.
2 is in terminal guidance.
Get into that coast phase. These views brought to you, of course, by ground stations across the track that are pulling in the high-resolution data from the cameras. Burn looking good, just a few seconds away from cutting off from that first burn. And there it goes. The first burn is
result, apogee, perigee, and everything for the mission looks really good. Engine performance, very well performance by the second stage for this first burn. And things continue to look good as we head into this long coast for this parking orbit.
It's a long coast, and we'll hit that second burn, roughly 3 minutes and 21 seconds long. This one was roughly 3 minutes and 9 seconds. And Mick, you saw the data from it, and it all looked pretty good. Then there you go, the confirmation.
We're hearing confirmation that we have nominal orbital insertion as we were looking at the telemetry here, Daryl, that things looked very good. Stage 1 and Stage 2 performed very well on that ascent flight, and we'll continue to follow Stage 2 to get ready for that second burn, and then, of course, what we're really looking forward to, Europa Clipper separation.
It's going to be a beautiful moment. If the pictures are as clear as we've seen so far, we will see it in all of its glorious detail. All right. We will continue monitoring the coast phase of the second stage with Europa Clipper, and we will bring that to you. Of course, any updates that we have, we'll check back in with you in a little bit, but for now, let's send it back to the host desk with Megan and Jenny.
Oh, wow. I mean, if you're just joining us, welcome live to Kennedy Space Center in Florida, where we just saw a SpaceX Falcon Heavy rocket soar off the launch pad with the Europa Clipper spacecraft. I thought... I'm surprised you're here and composed, to tell you the truth.
Yeah, you did a good job of keeping me upright watching the launch.
Yeah, how are you feeling? How was it to see that and feel that, too? I mean, that was honestly one of the loudest and most powerful rocket launches that I've personally felt here on the Cape.
It was very emotional in a good way, right? Just kind of overwhelming with just the awe of it, and that it's finally going up into space, and I feel almost at a loss for words.
Yeah, I know. She was like, I am sobbing. She just kept saying, I am sobbing. I am sobbing. I mean, but everybody can understand that, right? I mean, and this is one of my favorite parts of being part of the broadcast, because I do get to watch it with the co-host, and really, this is so much of your life that you're seeing culminate in a rocket launch.
It is. It's a huge, again, it's almost indescribable, just the amount of time and effort and all the people involved that got us to here, and to witness that moment is just unlike anything I can describe.
And can you believe it? We are still very much at the beginning of this spacecraft's journey. It is headed for Jupiter's icy moon Europa, which scientists believe could be the best chance of finding the ingredients for life outside our planet. It will take the spacecraft 5.5 years to travel the nearly 2 billion miles to Europa. This is a mission developed by NASA's Jet Propulsion Laboratory in California and Johns Hopkins University's Applied Physics Laboratory in Maryland. Now, Jenny, why does the team think that Europa is the best chance of finding those ingredients for life as we know it?
Yeah, on this planet, everywhere we find water, we find life. And so, that we think that there's this massive ocean of water underneath the ice on Europa is just, how could you resist, So we think that Europa has that water. That's one of the key ingredients for life, along with the chemistry and the energy and the time. It's been kind of simmering away for a long time.
Sure.
It's a great place to go explore.
And how exciting would it be, right, if we could verify that there are the makings of life as we know it on Europa. So let's dig into the science that is going to make this possible.
We have several ocean worlds in our solar system. And by exploring Europa, we're getting a taste of what these ocean worlds are like. Europa probably has beneath its icy surface a global ocean of water.
We think there are thermal vents in this vast subsurface ocean. There may be primitive organisms there, similar to the original primitive organisms on Earth from which we all evolved.
I just love Europa's surface. I think it's one of the most complex surfaces in our solar system. Typically, when you look at another planetary surface, it's covered with craters, just like our moon.
There are shockingly few impact craters. So that means something is going on to erase the craters, just like happens here on Earth, and on Earth we call that geology. One of the key questions right now that we have about Europa is whether or not there's plume activity.
Plumes are one way that you can definitely get ocean material to the surface. We really need a spacecraft in the system that's watching Europa to see when those plumes are happening, if they're happening. Europa Clipper is orbiting Jupiter, and it's performing 49 flybys of Europa.
Each time we make a flyby, we turn on all of the instruments at once.
Most of us know about cameras because that's what our eyes see, but there is a whole slew of other instruments on board Europa Clipper that expands our vision.
We have 4 different instruments that we're really using to take images of Europa's surface. We have the visible wavelength, the near-infrared, the far-infrared, and the UV, the ultraviolet.
We're hoping to see evidence of change, new cracks, new surface colors that indicate different materials maybe have moved around or come up from the subsurface.
We have an instrument that can sniff the very thin atmosphere, the gases, and determine the composition with extreme precision. And we have another instrument that can tell us the composition of dust particles.
We have a magnetometer and a plasma instrument that are going to be studying that magnetosphere environment that Europa is sitting in and Jupiter's magnetosphere environment.
The magnetic field of Europa, in turn, can tell us about the properties of the ocean. How thick is it, and how salty is it?
And then we have this novel ice-penetrating radar that will try to get below the ice shell.
last but not least, we have a gravity experiment using the communication system of the spacecraft. And from that, we can get essentially a map of the gravity field.
We can get the shape, understand, what's underneath, maybe even get some information on the depth of the ocean. It's really a sophisticated payload.
The pictures that we are going to get back are going to be just fantastic.
The legacy of Europa Clipper will be just a treasure trove of knowledge about this world.
Just to find an environment that is similar to the one from which life arose on Earth would really be groundbreaking. It would be awesome.
We don't know if Earth is the only place that life got started or if it's really common. And a really important way to get at that is to understand, is there life elsewhere in our solar system?
And we were proud to host JPL directors here at Kennedy for launch. She's with Tony now, and they both had a spectacular view of launch.
That's right, Megan. What a spectacular sight indeed. And like you mentioned, we have a very special guest with us, JPL Director Lori Leshin. Lori, congratulations first off on what a beautiful launch and now an exciting mission ahead.
What a great day. We're so excited. Thanks to SpaceX for the fabulous ride.
Absolutely. And, Lori, what would you like to say to the teams who have put in so much hard work and dedication, to this mission?
More than 4,000 people across many different organizations have worked on Europa Clipper, and we're so proud of them and so grateful for their hard work, for their families who've supported them, and especially the 150 or so with us from JPL who rode out the hurricane here. Thank you.
Absolutely. And, can you tell us a little bit more about why planetary missions are important in general that we go and study?
Well, it's really about who we are. Even though it's a robot we're sending out into space, it's a very human endeavor to want to explore the unknown, and especially to want to understand where life came from, how we originated, whether there could be other life out there. It's really a fabulous quest, and we're so fortunate to be able to do that.